So my name is Blerina Spahiu and I am an assistant professor at the University of Milano-Bicocca in Milan, Italy. So ensuring high quality in the LOD ecosystem remains one of the most pressing and complex challenges for real-world application. LOD is rooted in openness and decentrality. And while the openness enables reuse and, of course, innovation, on the other hand, it introduces challenges to guarantee the level of reliability that these real-world applications should need. So one of the fundamental challenges is heterogeneity. So the LOD or knowledge graphs are being published from different publishers. They are modeled using different ontologies, different vocabularies, and they also have different level of abstraction. So bringing together this perspective into a coherent knowledge graph requires careful alignment and interpretation. And without this, the interoperability that this real-world application need becomes vulnerable. So sometimes they suffer from semantic mismatch. Closely related to this is also the issue of trust and provenance. In principle, anyone can publish RDF triples on the web and they can link them with existing entities. But not all the data have the same level of authority and reliability. And for some applications in some particular domains, for example, clinical research, it is not important to know that the dataset exists, but it's equally important to know who created it, how it has been maintained over time, and whether we can trust it or not. And unfortunately, provenance metadata are often missing or incomplete. Many LOD datasets are partial. They provide just a skeletal description for entities with large gaps for relationships or attributes. They sometimes contain erroneous information or even outdated information. There exist many quality metrics that capture this kind of errors, but they fall short in capturing the nuanced domain-dependent that real applications need. So the level of accuracy for a dataset in a particular domain, for example, tourist recommendation, it's not acceptable for an application in clinical research. And this underscores a very important truth, that data quality is not an absolute property of the data, but it's contextual, so it depends on the domain and on the use case. Another challenge is entity linking. So the promise of LOD is that you can link different sources with the links, but these links can be broken over time because datasets evolve. So without a clear maintenance plan, then we are littering knowledge graphs with broken links or even misleading connections. Equally important are two other dimensions, so societal and institutional dimension of quality. Many of the datasets out there are published one and then abandoned. So broken URIs or Sparkle endpoint URLs that are not working are just too common, and all these issues threaten the stability of real-world applications that are built on top of this data. So addressing these challenges requires not only technical solution, but also maintenance plan, something similar that open source software community has reached over time. All these challenges underscore a very important message that quality is not a single problem to be solved, but rather is a constellation of interrelated issues such as semantics, trust, ethics, and so on. And we should all recognize that data quality should be defined in the context of the domain or the use case or the specific use case. So the convergence of machine learning and knowledge graph has the potential to transform both fields enabling systems that are not only more intelligent, but that are more reliable and adaptable. So from the perspective of machine learning, one of the primary contributions of LOD, or knowledge graphs in general, is structured background knowledge. Knowledge graph contain information about entities, relationship, ontological constraints that can be used as priors for machine learning algorithms. And rather than learning patterns from raw data, machine learning can be guided with this structured knowledge in order to reduce ambiguity, to improve generalization, or to enhance, for example, interpretability. Many machine learning systems are data hungry, so they need a lot of labeled data for training. But in some domains, the amount of available data is limited. So machine learning can use structured knowledge from LOD, for example, in order to, capture some information about entities, relationship, ontological hierarchies, in order to compensate for this limited amount of labeled data. And finally, using these cross links between data sets, machine learning can effectively transfer knowledge from one domain to another domain in order to reduce the need for labeled data in a particular domain. On the other hand, machine learning can be used to improve the usability and quality of LOD datasets and knowledge graphs in general. So knowledge graph provide information about entities and, as I said before, relationship, but they suffer from a lot of issues such as inconsistency, completeness, or noise. And machine learning algorithms, particularly from the field of representation learning and neural networks, can be used to, for example, improve the quality of knowledge graphs by introducing new links, so by completing the knowledge graph, by doing link prediction, entity resolution, and so on and so forth. In a sense, machine learning can be used as a self-healing mechanism to fill these gaps and improve the quality of knowledge graphs. One of the criticisms of modern machine learning algorithms and particular deep learning, is their opacity. So the output of these models is difficult to interpret. And by grounding machine learning output into knowledge graph, into this structured knowledge, for example, by aligning their predictions with semantic relationships, or by tracing back decisions using knowledge graph paths, then we are contributing in making this final decision more interpretable, because we know how the model reasoned. So the combination of knowledge graphs and machine learning enables a new generation of systems that are not only more intelligent and they have the ability to reason, but also to learn and adapt, so evolve with time. So working on different European and regional Italian initiatives has highlighted how important collaboration is, and not only how important it is, but also how challenging it is to bring all these initiatives together. Each stakeholder brings their own strengths, but they also have different priorities. So the real challenge here lies in finding ways to reconcile these criteria, these strengths and these needs into a coherent and shared vision. The main contribution from the research part has been more in the methodological robustness and innovation. However, the results from the research travels with a different pace rather than government or companies. And sometimes the research contribution risks to remain isolated from operational needs. So the main lesson here has been to embed researchers early in the policy and infrastructure planning of the whole process. Government has the right data, and they also have the duty to publish this data in an open format. But however, as we all know, they face different challenges. And one of the challenges is because they have fragmented IT infrastructure. Sometimes they do not have the right skills to keep this process at scale. And sometimes they suffer by this check-the-box mentality where they publish data set in an open format just because of compliance, not because they think about their genuine reuse. And industry, of course, contributes with a totally different perspective because they are more focused on services that work, so not the theoretical part. Companies contribute with a totally different perspective. They are more interested in the practical side of all the applications, and they measure success by the value they create. And sometimes this goes against openness, especially when the business model is built on top of proprietary enrichment of public data. So bringing together all these three worlds is very difficult, but it is something that cannot come automatically. It's something that we need to build. Government can contribute with their data and their policy, researchers can ensure quality and also innovation, while companies transform this data into impactful services. Another important lesson is the need of shared standards and interoperable frameworks. And at the European level, there are already some initiatives. There are two projects, the interoperable European initiatives and European data spaces, that have highlighted the importance of shared vocabularies and metadata profiles, so that this local data set do not remain, let's say, local curiosities, but they are part of a larger vision, such as the data space.